Well, when we're going to find the area, what we need to do is integrate the curve with respect to x between the limits 0 to 2 pi. So I'm going to put that in as the area equals the integral from 0 to 2 pi of y with respect to x. And y being the curve, and the curve here is 3 sine x upon 2. So I'm just going to fill that in underneath as equaling the integral then from 0 to 2 pi of y, which we now know is 3 sine x upon 2 integrated with respect to x. Don't forget the dx on the end there. Okay, so put equals underneath the last equals. Now we should know how to integrate sine of a function. It's going to be negative cos of that function. So what we're going to have then is 3. I'll put some square brackets, by the way, so let's just put some square brackets in there. So it'll be 3, and the integral of sine then is negative cos, so that's negative cos of the angle x upon 2. But we must remember that we're multiplying the x here by a half. It's a half x, and when you integrate you would divide by that half, so dividing by half really means that you will get 2. Okay, let's close off the square brackets and put the limits in from 0 to 2 pi. Scroll up a little. Okay, so equals. We'll just tidy this up first before we substitute the limits in. So we've got 3 times 2, which is 6, times a negative 1 here. So it's going to be minus 6. And it'd be easier if we just put it outside the square brackets. So put the square brackets in, and then we've got the cos of x upon 2. And that's going between the limits then of 0 and 2 pi. Equals again underneath, and we'll substitute the limits in. So we have minus 6, and then putting the 2 pi in for the x, we've got the cos of 2 pi over 2, and 2 pi over 2 is the same as pi. Then minus the cos, and then we're putting the 0 in for x. 0 divided by 2 is 0, so it's the cos of 0. Close that off. And then working this out, we have minus 6. The cos of pi, should know, the cos of pi is negative 1. So that's negative 1. And the cos of 0 is 1. So that's that negative there we put in, and the cos of 0 is 1. So in the brackets we have negative 2, and minus 6 times negative 2 is going to give 12. And because it's an area, I'm going to write that it's square units. So the area is 12 square units, or you could write units squared. Okay, so that's part A done, and if you did that, you would have got 3 marks. So I'll put that down then as 3. Okay, we're moving on now to part B, so we'll just scroll up a little. Now in part B, we're asked to find the volume of the solid generated when the region is rotated through 2 pi radians about the x-axis. So we've got to find the volume of revolution then when the region is rotated through 2 pi radians about the x-axis. Okay, so you might like to pause the video, come back to check your answer. Okay, welcome back. Let's see how you got on with this one. Now to find volume, the volume is always equal to pi times the integral of y squared with respect to x. And our curve is going from x equals 0 to x equals 2 pi. So there'll be my limits. Okay, so put the equals underneath, and we have pi. And let's just fill in what y squared would be. We're going from 0 to 2 pi. Now y was 3 sine x upon 2, so if we square that, we're going to have 3 squared, which is 9, times the sine of, or sine squared I should say, of x upon 2, integrated with respect to x. Okay, so I'm going to pull the 9 out the front. It's always good to pull constants out the front. So then I'm going to look at trying to integrate sine squared x upon 2. So put the integral sign in, 0 to 2 pi. Now to integrate a sine squared function, I'm going to call upon the identity cos 2a. So let's just draw this in the margin here, just to recap what this is about. Cos 2a, okay, is identical to 1 minus 2 sine squared a. And if we rearrange this to make sine squared a eventually the subject, I can add 2 sine squared a to both sides, so I get 2 sine squared a, and at the same time subtract the cos 2a from both sides. I get that 2 sine squared a is identical to 1 minus cos 2a. And if I divide by 2, I'm therefore going to get that sine squared a is 1/2 of 1 minus cos 2a. I always prefer to write 1/2 of 1 minus cos 2a rather than all over 2. You'll see why in a minute. Because what I'm going to do is that sine squared x upon 2, my x upon 2 is now the a. So this is going to be 1/2 1 minus cos twice x upon 2, in other words cos of x there. And this half I'm going to bring out the front, so it would be 9 pi over 2, and then I have 1 minus cos of simply x with respect to x, using the identity. Okay, so it looks fairly uncluttered in here rather than having it all over 2. As I say, I brought the 2 out the front. Okay, now all we need to do is just integrate this. So we have our constant out the front, 9 pi over 2. We're ready to integrate, so I'm going to put some square brackets here. And the integral of 1 with respect to x is x. And the integral of minus cos x with respect to x is minus sine x. So that goes in like so. And we have our limits from 0 to 2 pi. Substituting the limits in, let's just go there. We have 9 pi on over 2 at the front, and so we have, first of all, putting x as 2 pi, we have 2 pi minus the sine of 2 pi. Let's put that in brackets there. Then we put the 0 through, so minus, put the 0 through, that's going to be 0, so I won't bother putting that in, and minus the sine of 0, so I put minus sine 0. Okay, which equals 9 pi upon 2, and then we have 2 pi. Now the sine of 2 pi is 0, so that goes, and then we have sine of 0 down here is 0, so that's gone. So we just simply have 2 pi. So 9 pi of 2 times 2 pi, the 2's cancel, just leaving me with 9 pi squared. And because this is a volume, I'm going to write that it's in cubic units, or you could write units cubed. Okay, cubic units. And if you did that, that's going to be worth 6 marks. So well done if you got that far. And that brings us to the end of question 3.